Hello, detective math student, and thank you for taking up the case. You won't believe what's happened. Two numbers came by here and they graffitied everything inside these middle school math students' walls. I'm going to show you in a moment what they did. But please, be aware, it is very disturbing. You might want to turn your head away. It doesn't end. With your hard work, I think we can get them. And please, we need to get them soon. We can't let them cause any more destruction. We were able to interview some witnesses, and the only thing we came up with was this. The two numbers have a sum of 11. And the other witness said the same two numbers have a difference of 3. So I just don't know where to begin. They could have a sum of 11, but 9 and 2 only is a beginning. They could be 9 and 2. They could be 8 and 3. They could be 7 and 4. They could be 6 and 5. They could be 5 and 6. The last thing we want to do is take in an innocent member of our society of numbers. But we need to question all of them because there's just too many ways to get a sum of 11. Heck, the witnesses didn't even say if they could be negative numbers. And then, of course, the numbers also have a difference of 3. We've already taken in 10 and 7. They looked suspicious to us, but they're not the only ones. It could be 9 and 6. It could be 8 and 5. Our team of researchers can only get us so far. So now we're starting to narrow in on some ideas, but you can tell the list. I mean, we could even go to 197 if we wanted to find numbers that have a difference of 3. It just seems like there's no potential answer. Help us dig in a little bit deeper. Okay, so clearly these numbers all have a sum of 11. So let's just say one of the numbers is x. And another of the numbers is y. Together, they must form 11. And if we were to manipulate this into a slope-intercept form equation, we could take x on both sides and take x over here. And now I have an equation that says y equals the opposite of x plus 11, where 11 is my y-intercept. And if we graph that, okay, now we're looking at some potential numbers here. But again, there's so many innocent numbers on this, and this list just goes on and on and on. But it helps give us a visual clue. Let's see what else we have about the differences. Well, if we take the fingerprints of them, it looks like each time to get from x to y, there is a pattern, but what is it? Let's look at, this was something that was left by supposedly the criminal at one of the scenes. They left this sheet of paper, but we can't uncover what it means. Maybe if we... There it is! Y equals x minus 3. That rule makes sense. If we take 3 off of x each time, we end up with y. Huh. Unbelievable. Now, what if we took this clue with what we found earlier about the sum of 11? Can we match those two up? Look at this. Look what our lab team just brought back. They seem to meet at this one area. It's 4 and 7. Could that be? 4 and 7, were they on? There they are. There's 7 and 4 on our list. They seem to have a difference of 3. But were they on the other list? Yeah, they have a sum of 11. Huh. So there you go. X is 7. Y is 4. We got them! Great job! Now we can get back to a world where we can get better.